Today we're talking about structure, and more specifically, structural fragmentation, what it is, why it happens, how it hurts your data work, and what you can do about it. This is a gentle, practical walkthrough, no jargon-heavy detours, so whether you're just starting with data or you've been doing this for years, you'll get something useful. Let's begin with a quick idea. When we talk about structure in data, we mean the consistent shape and organization of records, the fields, types, relationships, and constraints that let us reason about data reliably. Structural fragmentation is what happens when that shape splinters. Different parts of your dataset use different schemas, different field names, different types, or different ways to model the same concept. The result is a fractured dataset, pieces that should fit together but don't. Here's a simple example. Imagine a customer dataset. In one source, the customer's birth date is stored as year, month, day format. In another system uses month, day, year format. In a third, age is stored instead of date. Same concept, 3 different structures. During analysis, you either waste time normalizing these formats or you risk silently producing wrong results. That's structural fragmentation. Why does it happen? There are a few common causes. First, system drift. Teams build or extend systems independently and don't align on a central schema. Second, historical baggage. Legacy systems carry old models that never got consolidated. Third, context-specific models. Different teams model data to fit their immediate needs, which is fine locally but costly when you need to combine data. Fourth, rapid iteration and MVPs. You ship fast, and structure becomes inconsistent over time. What's the real harm? Fragmentation increases friction at every stage. Ingestion becomes harder because pipelines must detect and transform multiple shapes. Data quality checks miss edge cases because rules assume only one schema. Feature engineering becomes brittle. A model trained on one variant of the data will break when fed another. Finally, fragmented structure hides semantics. It's harder for humans and machines to agree on what a field actually means. So how do you detect it? Direct. Start with simple analytics. Run a schema profiler across sources and look for mismatched field names, types, and null patterns. Sample data, not just schema declarations. Declarations lie. Visualize distributions for comparable fields. Mismatched value formats or ranges are red flags. Track lineage. Where did this field originate and how has it changed? And monitor downstream failures. A spike in ETL errors or sudden model performance drops often point back to fragmentation. Next, how to fix and prevent it. Prevention is always cheaper than cure. Actionable. Establish a lightweight canonical model, a minimal, authoritative description of key entities and their essential fields. You don't need a massive enterprise ontology. Start with the critical tables used across teams. Steady pair that with automated validation. When data arrives, run schema checks and emit meaningful errors or warnings. Version your schema and roll out changes through a governed process so teams can adapt. For existing fragmentation, follow a 3-step repair pattern. First, discovery. Map the variants and prioritize by impact. Second, normalization. Implement transformation layers that translate variants into the canonical model. Advising. Do this in the ingestion layer so most consumers get the same structure. Third, consolidation. Communicate changes, deprecate legacy variants, and provide libraries or shared services that return canonical data. There are useful engineering practices to make this durable. Use contract tests between producers and consumers, maintain a lightweight data catalog with examples and expected formats, and provide small, reusable transformation utilities so teams don't re-implement the same normalizers. Automation is key. Make the checks part of CI/CD and the pipeline so fragmentation is caught early. Finally, think about organizational design. Structural fragmentation is often a symptom of disconnected ownership. Creating clear ownership for core domain entities and encouraging a data as a product mindset will reduce ad hoc modeling choices and make structures stable and discoverable. To wrap up, Structural fragmentation is common, avoidable, and fixable. It steals time, causes errors, and weakens models, but with a canonical model, automated validation, and clear ownership, you can bring your data back together. If you take one thing away today, start profiling your schemas across sources this week. Even a small map of mismatches will show where to focus. See you in the next one.